You've heard the phrase 1,000 times, that star is 4 light years away. And your brain quietly translates it into a distance, like miles, like kilometers, like a ruler stretched across space. But here's the trap. A light year is not a distance in the way your mind thinks distance works. Not in the universe we actually live in. Not in a universe where time is stitched into space so tightly that separating them is like trying to separate left from right. A light year is a warning label. It's the universe telling you, if you talk about how far, you're also talking about how long. And the moment you pretend you can keep those ideas separate, everything you believe you understand about reality starts to wobble. Let's start with something that feels solid. If I ask, how far is your kitchen from your bedroom? You can answer with a distance, 10 meters, 30 feet, whatever. The point is you imagine a single objective gap in space. And if I ask, how long does it take to walk there? That's a time, 5 seconds. In your everyday life, distance is distance and time is time. 2 separate drawers. Now watch what happens when I ask a different question. How far away is lightning? You don't actually know the distance directly. You see the flash. Then you count 1, 2, 3, and then you hear the thunder. You turn time into distance using the speed of sound. Distance wasn't measured with a ruler. It was inferred by a signal, by cause and effect, by the travel time of information. That's already the first crack in the wall. In practice, most distances we care about are really signal times, wearing a distance costume. Now replace sound with light. You see a star? That star is not over there in the way your kitchen is over there. A postcard arriving late. When you say 4 light years away, what you're really saying is the star you see is 4 years old. You're looking into the past. And that's still not the weird part. The weird part is that in our universe, how far depends on who you are and how you move. And once you accept that, you realize a light year can't be a simple distance because distance itself is not a single universal thing. Here's the pivot that collapses the usual picture. Imagine 2 events, a supernova explosion and you detecting its light on Earth. Most people imagine there's a true distance out there between Earth and the star, and light just takes time to cross it, like a bullet traveling down a hallway. Because the hallway is not just space, it's space-time. And in space-time, different observers slice reality into space and time differently. They don't disagree about the space-time interval, the combined geometry, but they absolutely can disagree about the distance and the time separately. So when you say 1 light year, you're smuggling in a whole coordinate system. You're choosing a particular way to cut space-time into nows, and then measuring space inside that chosen now. That's not a pure distance, that's a space-time statement. If you want the mind collapse version, here it is for a photon. The distance between its emission and its absorption is 0. 0. Not very small, not kind of 0. And that's not poetry, that's geometry. This is where Feynman's way of thinking hits like a hammer. Feynman loved stripping away words until only operational meaning remained. What can you measure? With what? And in what frame? So, ask the brutal question. What does it mean to say 2 things are separated by a distance? It means you can place them both on the same time slice of your frame, your definition of simultaneity, and then measure the spatial separation on that slice. But simultaneity is not universal. 2 observers moving relative to each other do not agree on what counts as at the same time. So the distance at the same time is not universal either. That's why calling a light year a distance is like calling a movie runtime a length and acting like it's the same kind of length as a rope. Yes, you can convert minutes into feet if you know a speed, but the conversion isn't innocent. It carries the physics with it. And the speed that does the converting, the one baked into the universe, is c. People talk about c like it's the speed of light, but that name is historical. It's a misdirection. C is the speed of causality. It's the conversion factor between time units and space units in the fabric of reality. We only notice it through light because light is the cleanest messenger we have. Now let's make this concrete with a thought experiment that looks harmless and then turns lethal. You're floating in deep space in a sealed spaceship. No windows, no reference points. You're drifting in the middle of the ship. You flash a light. The light spreads outward as a sphere. You measure how long it takes to hit the walls. You conclude, light moves at c. So far, boring. Now imagine someone else watching your ship zoom by at a huge fraction of c. They also measure the light. They also conclude the light moves at c. That sounds like agreement. But here's the impossible puzzle. If your ship is moving, shouldn't the light have to catch up to the forward wall and meet the backward wall sooner? Shouldn't one side be easier than the other? That's what every human instinct says, because that's how balls, bullets, and waves in air behave. And this is exactly where the universe forces you to choose between two options. Either the speed of light is not the same for everyone, or space and time are not what you think they are. The universe chooses the second. To keep C fixed for everyone, the universe makes time flexible and space flexible, not as illusions, as literal physical facts. Moving clocks tick slower, moving lengths contract, and the amount is not arbitrary, it's exactly the amount required to keep C unchanged. This is the moment where light year stops being a casual unit and becomes a confession. Because if time and space trade with each other depending on motion, then any unit built from light and time is automatically entangled with the deepest structure of space-time. So let's expose the punchline with numbers, because numbers force honesty. 1 light year is the distance light travels in 1 year, but you can also say 1 year is the time it takes light to travel 1 light year. That sounds like a neat conversion. Until you ask, whose year, whose clocks, and whose frame are you defining that year? Because in relativity, 1 year is not a universal chunk of reality. It's the reading on a particular clock following a particular path through space-time. And that's where the phrase, light year is a distance, quietly fails. It's a distance in the rest frame of the object you're measuring from, using that frame's notion of simultaneity. Change the frame, change the distance. The space-time relationship stays invariant, but the split between space and time does not. Here's the version that makes people uncomfortable. If you chase a beam of light at 99.9999 to C, you still measure the light moving away from you at C. So in your frame, light covers 1 light year in 1 year, because C is C. But your clocks are running slow relative to the Earth frame, and lengths in your direction of motion are contracted relative to the Earth frame. So what 1 light year means depends on which set of rulers and clocks you're using. Same phrase. Different physical slicing of reality. Now, let's take it even deeper, because this is where Feynman style really shines. Stop worshiping the unit and look at the geometry. In space-time, there's a quantity called the interval. It's like distance, but in space-time, not just space. For two events separated by some time and some space, the interval is stu, that minus sign is the entire plot twist of the universe. It tells you space-time is not like a regular 3D room with time added as another direction. It's a different kind of geometry. And light lives on the boundary where stu 0, that's what moving at C really means. Light follows paths to space-time with 0 interval. Now read that again slowly. 0 interval. That means there exists a sense in which the space-time distance along a light path is 0. That's why in the math, light is the thing that defines the causal structure. So a light year is not merely a distance light travels. It's a way of packaging a space-time interval into a spatial-looking number by multiplying time by C. It's time wearing a distance mask. Now, here's the part that collapses your intuition about distance itself. When cosmologists say a galaxy is 10 billion light years away, they're often not even talking about the same kind of distance you're imagining, because the universe expands. Light traveling toward us is moving through space while the space itself stretches. So there are multiple distances you can define. The distance now, the distance then, the distance inferred from brightness, the distance inferred from redshift, the comoving distance, the proper distance. They're all legitimate and they can differ wildly. So light years away in cosmology is often shorthand for light travel time, not a rigid ruler distance. We keep using the word distance because language is sticky and because your brain likes pictures, but the universe doesn't care what your brain likes. Now let's bring in the Feynman punch that really makes the title true. Why would this collapse your mind? Because it reveals that your default mental model space as a stage, time as a universal drumbeat, is not reality. Reality is closer to this. Events are the basic things, not objects sitting in space. Events, something happens somewhere, sometime, and different observers carve the same set of events into space and time differently, like taking different cross-sections of the same Ford sculpture. So when you say, that star is 4 light years away, you're making a statement that only has meaning within a chosen carving. If you want an absolute observer-independent statement, you don't talk about distance or time separately. You talk about the interval. And along light's path, the interval is 0. That means light is not just something moving through space-time. Light is the ruler that defines space-time's geometry. It's the thing that tells you what future and elsewhere mean. Now let's flip it, because this is where people feel the floor disappear. Suppose you travel to a star that is 4 light years away at a speed extremely close to c. From Earth's perspective, the trip takes a little over 4 years. But from your perspective, because time dilates and distances contract, the trip can take much less than 4 years of your own time. So did you travel 4 light years? Earth says yes. You say the distance was shorter, and both are right because distance is frame dependent. But here's the killer. The light year as a distance unit was defined using Earth-like clocks and an Earth-like slicing of simultaneity. If you insist it's a distance, you're forced to accept that distance is not absolute, and the unit is not universal in the naive sense. So what is it really? It's a conversion. It turns time into space using the fundamental structure constant c. It's a space-time unit. It's measuring along the light cone structure of reality, not along some absolute cosmic grid. And if you want the cleanest, simplest sentence that captures the whole idea, here it is. A light year is how far light goes in your coordinate system, and coordinate systems are not the universe. Now the final mind collapse comes from one more step, the causality angle. When you say 1 light year, you're also saying 1 year of causal delay. If something happens 1 light year away, nothing you do can know it sooner than 1 year, and nothing you do can affect it sooner than 1 year, because information can't outrun light. So the distance is inseparable from the causal structure. That's not like meters, that's not like miles. Those are human-scaled labels for spatial separation on a shared time slice. A light year is a bound on connection, a bound on influence, a bound on when now can become then for you. It's not primarily geometry, it's causality dressed as geometry, and this is why the speed of light isn't just a speed, and why a light year isn't just a distance. Because the deepest thing relativity teaches is not things go fast. It's that the universe has a built-in limit to the propagation of cause and effect, and every measurement you call distance is secretly an agreement about simultaneity, and simultaneity is not universal. So the next time you hear, this star is 100 light years away, hear the real sentence underneath it. This is the 100-year radius of our causal past, in a particular frame, drawn using the geometry that light defines. That's what a light year really is. Not a line on a ruler, a slice through space-time, a boundary on what can touch what, a unit that only exists because the universe welded space and time together and left c, and once you see that, you can't unsee it. Because the phrase light year stops being astronomy vocabulary and becomes a reminder that space is not a place and time is not a river. They are one thing. Question.